All right, this time we're going to talk about hyperbolas, which is section 8.3 in your book. And what we're going to learn about with the foci and the hyperbola is that this length with the red and the blue line this time, the difference between the two of them is a constant value. Notice that it's 2.84, and if I switch to the right-hand side, it's still 2.84 is the difference between those two values. And you could change your major axis or your axis, and notice like now that the axis is almost right on the foci, and if I bring it farther in, you'll notice it's a little bit farther from the foci and the distances change. So this gives you an idea of what a hyperbola looks like. So we're going to talk about some notes with the hyperbola. And with the hyperbola, we have the biggest difference is the formula. And if you'll notice for the formula for the hyperbola, that the biggest difference is that our formula is a subtraction problem as opposed to addition. You'll notice that the a and the b values are always constant. A is always the first term and b is always the second term. B is always attached to the minus sign. So if you look at this one, B is attached to the minus sign. So since A is under X, that means that this hyperbola is going to be symmetric about the x-axis. And this one, since A is under Y, it's going to be symmetric about the y-axis. So this one, your hyperbola is going to go left and right, and this one's going to go up and down. The other thing you'll notice is that to find C on this one, you are going to do Pythagorean theorem, so it's a squared plus b squared. The foci are still on the same axis as A, so A is still considered your major term, and C is still going to be on the same axis as A. In this case, we're not really going to use B for graphing, except for the asymptotes. And we're going to talk about the asymptotes as we graph these problems. Okay, so here we have a few examples. So if you'll notice this, so the bigger value is under X, so A is equal to 5 and B is equal to 16. B is equal to 4. And then C would be a squared plus b squared. So that's going to be 51. So it's the square root of 51. Okay. And then if you notice that since it's since the bigger value is under X, that this hyperbola is going to be going left and right. On this one, A is going to be 5. B is going to be 4, but you'll notice that the A value is under Y, so that means that it's going to be opening up and down. Okay, on this one, A is 6, B is 3, A is under X, so that means it's going to be opening left and right. On this one, we have a center of 2, -1. A is 6, B is 7. Since A is under the Y value, that means it's going to be opening up and down. On this one, we're at -4, -3. A is 4, B is 3. Since the larger value is, oh, I messed up over here. Since oh, no, I didn't. A is under X on this one, so that means that it's going to be opening left and right. So in these problems, A does not have to be bigger than B, so you have to keep that in mind as you're going through these problems. Okay? Now, since this problem has X first and Y is negative, that means that we're going to be looking at our first formula, which has X first and Y is negative, and that means my asymptote is going to be B over A. So that means my asymptote here is going to be, it's going to have a slope of plus or minus 4/5. This one, since the y is first, my asymptote is going to be reversed, and it's going to be a over b instead. So that means it's going to be plus or minus 5/4. Since x is first, it's going to be plus or minus 3/6, which is plus or minus 1/2. On this one, since y is first, it's going to be plus or minus 6/7. And on this one, since x is first, it's going to be plus or minus sorry, I lost my train of thought, 3/4. So we're going to use this information to graph our hyperbolas. Okay, so to graph it, we're going to graph our a value, or first we're going to graph our center, which is 0, 0. And then we're going to graph a, since we know it's going left and right, we're going to go to 5. And we're going to go to -5. And then we're going to use our asymptote to graph the asymptotes and use that information. So from the center, we're going to graph our slope of up 4 over 5. And then we're going to also go up 4 to the left 5. So our asymptotes are going to be this line right here and this line right here. Okay, and then we can use that information to graph our hyperbolas because we know how wide we need our hyperbolas to be. Okay, so let's do one of these examples where we have a center that's not at the origin. So here we have a center at 2, 1. So we're going to go to +2, -1. This one's opening up and down, so that means from here I'm going to go up 6, and I'm going to go down 6. Okay, from our center I'm going to graph my slope of +6 and 7. Okay, and so that means one of my asymptotes is coming right through here. Okay, and the other asymptote I'm going to go +6, -7. And so here's my other asymptote. And then that tells me how wide my parabola should be because I know that my my hyperbolas should be asymptotic to those lines. Okay? All right, so on this next one, they're giving you the foci and they're giving you the vertices. So that means that we know what C is and we know what A is. So now I can use that information to find B. So again, C squared equals A squared plus B squared. So I'm going to have 25 equals 9 plus B squared. So B squared equals 16. So B is equal to 4. So I don't really need to know the B other than to write my equation. So since my vertices are at 0, 3, so 0, 3 and 0, -3, that means that it's opening up and down. So that means I have to have y at the top, and my a value is 9, and I have to have the b value, which is 16, below the x, and that's going to equal 1. Okay, so here's another one, and on this one, since it goes 5 and -5 are my vertices, I'm going to have 49 equals 25 plus b squared. So b squared equals 24. So b is equal to the square root of 24. So when I do my formula, I know it's going to be x squared first and a is always going to go with this. Oops, I'm sorry, it's supposed to be minus, and then it's going to be y squared over 24 equals 1. So our last thing is we're going to do another problem like we did the last time, where we're solving this problem by completing the square. So we're going to start this off the same way that we did the other one. We're going to start by grouping our x's and grouping our y's. Make sure you carry that negative sign with you for the y's. I'm going to factor out the 4, and so I get x squared minus 6x. And then completing the square, half of 6 squared gives me 3 squared, which is 9. And then y squared and 10y, half of that squared is 25. The 153 was moved from that side to the other side, but then I have to remember to add the 36, and I have to subtract the 225 because that's a negative 9. So I have 4, and then I have x minus 3 once I do my trinomial square, and I have y plus 5 squared. This ends up to be negative 36. I would divide everything by negative 36, so I end up with x minus 3 squared and a negative 9, and y plus 5 squared and a 4. So my hyperbolas always have to have the minus sign in the middle. So this term, these two terms have to switch. So the y plus 5 comes first, the x minus 3 comes second, and so now I know that a is 2, b is 3, my center is the point negative 5, 3, and I have everything I need to graph that, and I could find my asymptote if I needed to. And because 4 is under y, that means that my hyperbola is going to open up and down. Okay, and here's the last one that we'll do real quickly. Again, we're going to group it, factor out the 4, so this becomes x squared minus 8x. Complete the square, so I'm going to put the 16 here. There isn't another term here, so I'm just going to write it down, but I'm not going to complete the square. The 164 was moved over here. I have to remember to add the 64 to that side, and there's nothing to add from here. So negative 164 and negative 64 and positive 64 is negative 100. So then when I divide everything by 100, I get x minus 4 squared over 25. And I end up with a negative here because of the negative 100. This becomes positive y squared over 4 equals 1. And then again, I have to rearrange it because I need that negative, I need this term to be in the middle. So I rearranged it again. So I end up with y squared over 4, x minus 4 squared over 25, and 1. So a is equal to 2, b is equal to 5, the center is 0, 4, and because the 4 is under the y, again, it's going to be opening up and down. Hope this helps.